So when we started, we used to say this thing that there's no one right way of doing something, right? Like there's no one right way of doing an interview. There's no one fixed way of even solving a coding problem, right? There can be many ways to do like the same thing, but usually what we try to optimize for is one good way, right? And if you vary that good way to any format you want, that is just up to you, right? So just learn like one good way, and then you can modify it as much as you want. So, for instance, if you ask me to tell you about myself, like that question, like tell me about yourself, I can give you an answer that I usually give, but that doesn't mean that if you see something different from that, you won't get an offer or anything. Maybe I got an offer from that company, right? But you can also add, something else to it, and you also get yours, right? So I just want you to be open-minded, even as we go over some of these things. That there's just no one right way. Okay. Um, so let me just create. I'm actually just setting up the platform here, and okay, so I want someone to, okay, can everyone see my screen? Can everyone see my screen?
Yep, I can see your screen.
Okay, good stuff. So I want someone to just choose any question for us, any liquid question. We're not going to solve it, so don't worry. I mean, maybe we might, but I just want to like show the format. So can anyone just choose any question here? Anyone? Or any liquid question you want to choose. I beg, don't go and choose some. One we are all going to struggle on. Just choose any question. Should we try two some?
Let's do maximum sap array. Maximum sap array.
Maximum sub, let's look for him.
Sap array.
Maximum sub array. This one, right? Is it this first one?
For that question is
Yeah,
what?
that one.
Okay. Yeah, let's do that. Let
No,
me.
no, it's fine.
Okay. Now let's move here. Okay. This one. Okay. Let's switch to this. Confirm. Okay. So I know almost everyone here, like many people have done technical interviews before, or even at least you've seen it on OA platforms. Should I show off and do C++? I mean, I'm learning C++. Okay, this one time for show off. I might even struggle. Okay, let's do the Python. Okay. So in a typical interview, you start with the first part is about the interviewer talking about you, right? Generally, talking to you and about themselves. So for instance, they start with, "Hey, I'm Cornelius. I'm currently this and this. I've been at this company for this number of years. I work on this team." And then, what about you, right? So one thing I tell people is that in an interview, the number one thing, you always want to connect with the interviewer. Now, as they are talking about themselves, you try to pay attention and listen to them. Truth is, even the thing they're saying, you may not even understand. I mean, they are like, "I work on this Azure data, creating this and this." You probably have no idea what Azure even is, right? But no one cares. He himself knows you don't even know what he's talking about. But then you have to listen, you have to show interest. You look at him, you smile, you nod, right? As if you know what's going on. That is how you connect with the interviewer from the start. It's so important. And sometimes people do interviews and they're like, "I solved the question perfectly, but I didn't move on." They forget that it goes beyond just the technical skills, right? How well did you connect with the interviewer? And one thing is, if you connect with the interviewer well, even if you get stuck in the coding portion, they're able to, come into play and then, help you. So even as we go through this, have that thing in mind, connecting with the interviewer. So they talk about themselves. They're like, "Okay, what about you?" If I'm doing a technical interview, that's non-technical portion about what about you. I try to keep my answers very short and concise, right? Because I want as much time as possible for my coding portion, right? Unless you're like super prepared, you're like, even if I have 5 minutes, I can solve the question or something like that. But I want to keep your answers brief and short. So, for instance, tell me about you. I'm like, "Okay, so I'm Cornelius. I'm currently a senior at Cornell University studying computer science. This summer I worked at Microsoft. Last summer I worked at Kayla and Facebook. This and this at Cornell. I'm a teaching assistant for a database systems class." That is all. I'm sure I'm done, right? I'm not now going to talk about. Don't go and talk about your projects. Don't going to talk about the things you did over the summer. Drill deep down. If they ask you a follow up to that, that is when you talk about that, right? But just tell me about yourself. You can just go very surface level, just hint at that. And because they have your resume with them, right? And on you go. If they want, they can drill down into your experience and into your projects. But if they haven't, for a technical interview, just try to steal away time, right? So that even if you use the first 5 minutes to talk about that portion, at least you have like 40 minutes to 55 minutes for the remaining part, right? So let's assume that part is done. So they're like, "Okay, now let's go into the coding question. Let's go into the coding problem." So this is a question I have for you. Then they paste the question. Sometimes you may be lucky to get 3 examples, right? Sometimes you just get one. It depends on the interviewer. And usually they don't give you the constraints. So LeetCode gives you the constraints down here, but generally in problem, they don't give you these are questions you ask, right? You can be like, "So what is the maximum size of our array of our length," right? And so on and so forth. But then let's take things more systematically. Give me a second. There's a bit of noise here. Give me like 3 seconds. Okay, they are gone. So ideally, what happens is that when they paste the question to you this way, an interviewer may ask you, "Should I read you the question? Should I read the question to you, or I want to read it yourself?" Whenever you get this question, please ask them to read it to you. Why? Because we said you're trying to connect with the interviewer, right? Now they can read it to you, and after that, you read it again, right? No one cares. But if they give a hand to help, just accept that help, right? Because it's a pair programming thing. So they read it to you. Given an integer array nums, find the sub-array with the largest sum and return its sum, right? So want the largest sub-array with its sum and return its sum. Then they'll explain example 1 to you. So if we take example 1, as you can see, the largest subarray is 4 minus 1, 2, 1. How did we get that? If you have minus 2 plus 1, that is minus 1, right? Then we have minus 1 plus 3, that is minus 4. So ideally, we could, discard this part, and then we can have 1 minus 3, that's minus 2. So that's like, for this whole subarray, the maximum sum was actually 1, right? Because 1 is bigger than, the minus 1 we got is bigger than everything, right? Then you come here we have 4 minus 1, that is 3. This plus 2, that is 5. This plus 1, that is 6. If you come here, 6 reduces to 1, right? You're like, 6 is bigger than 1, so I'll probably be, so 6 is the maximum we found so far, and so on and so forth. Now, as I explain this example to you, you have to follow them carefully, because sometimes I intentionally didn't explain this example well, but the moment I explain it so well, you know the algorithm, honestly. So after they explain the example to you, make sure you understand. If you don't understand the examples, don't even try to propose any algorithm. Understand the example perfectly. So they may explain one example to you. Then you take the remaining example. So you're like, okay, so for the second example, it's 1 because, okay, we have just 1. And so, okay, then you go to the next example. Make sure you walk through each of those examples, understanding each of the examples, and before you go into anything at all. So first thing, read a question, make sure you understand the question. If the question is like very wordy, you can simplify it, right? You can, remove some of the words the interviewer will understand. And you can even write a brief summary of it somewhere, right? That's something we'll do later. So then make sure you understand the example, every single, thing in the example, right? So that you understand why this example gave this output. So let's assume we are done now. So if I'm solving this question in an interview, you don't have anything like this, you don't have these function stubs and class stubs. So you can be like, okay, you start one with the doc string, especially those who do Python. If you do Java or something else, you can do the java.comments on multiple line, right? But you just do Python, we just do this doc string. That means anything I write in here, anything in here is simply a comment, right? So I'm like, okay, so what I'm going to do is I want the largest sum, right? So I want the largest sum, but it has to be a sub-array, right? From a sub-array. So I know that a sub-array, right, has to be contiguous, right? A sub-array means that like you can't just choose one and then skip minus and come and choose 4. It has to be contiguous, right? It has to be very contiguous. So you're like, okay, sub-array is contiguous. That's something you might not know, but they can. So when you're like, what's a sub-array? They can actually define it for you. It has to be contiguous or continuous. Anyhow, you want it to be. Okay. So you're like, okay, so what I'm thinking now is that let's take the first example. Whenever you're walking through the algorithm, please use your example first, because that's the only example you both you and them know the answer to, right? Is this not the time to create your own examples? Because if you can't even solve what has been given you, how then can you solve yours, right? So first start with your own example. Then you're like, okay, this is what I'm going to do. I'm going to start accumulating the sum. So let's say current, I'm going to have something called the current sum. What current is going to do, so I'm going to have my current here. So what my current is going to do, right, and then I'm going to have my result. So this is what I'll be returning. So current will be finding like the running sum, and then results will be, the maximum sum I've found so far. What I'm going to do is I'm going to have, let's say, what am I going to do here? Okay, let's say I'm going to, add all the numbers, right? So let's say I'm going to start from I, where I is my pointer and I is on the first number. And here I'm going to add whatever the number I is pointing to my current, right? So current is like my, my running sum, right? So I'm like, okay, so here it's 0 plus minus 2, right? And that gives me, minus 2. Now, see what I'm doing. As I'm going through it, I'm writing things down. Some of you just sit there and just say the sentence out loud. It does not work. Why? The interviewer might not even hear your accent. They might not even get your accent well. But if I write 0 plus minus 2 is equal to minus 2, this is math. Everyone understands it, right? So make sure you write out your algorithm. Make sure you write out your logic, your intuition, right? And the moment you write this, you can literally clean it up right now, right? Because they are looking at your screen and they know how you got the minus 2, right? Then I'm like, okay, then I move I forward to 1, right? So now I is pointing at 1. Then I'm like, minus 2 plus 1, right? And that gives me minus 1. But then you look at it, you're like, let's see something. Minus 2, here I've got minus 1 here, right? And this minus 1, look at something. This minus 1, right, is less than, that number I just found, that 1 itself. So, but then, the goal of this problem is to find the maximum, the maximum sum, right? And then a number itself can be, a sum, right? So you're like, when it resets to below 0, right, that's like I should just start afresh, right? So I'm like, okay, here I get -1, but I know that just this one itself is bigger than -1. So this guy is giving me like a negative loss. This guy is giving me a negative loss. The sum in which I came with is giving me a negative loss. So I'm going to just discard that, right? So I'm like, if I get negative, so I just write it here. I'll be like, note, like if current is negative, right, I just reset current to whatever I is pointing to, right? Nums of I, right? So let's pursue it like this. I'm going to reset it instead of -1. I'm going to reset it to 1 now. Okay. Then I'll move here. Then I'm like, okay, I is -3 now. So if I add -3, right, to this, I'm going to get, if I add -3 to this, I'm going to get -2, right? -2. I'm like, oh, -2 is lesser than the current I came with. That is 1. Oops, let's not forget. Oh, I have a result variable here. So I had to track this. So result is always going to be the max of whatever result is and current, right? So here current is 1. I came in with 1. And you know, when I add -3 to 1, I'm going to get -2, right? So I'm going to maintain my current as 1, right? I'm going to maintain my result as 1. I know I've lost a couple of people, but let's move on. Okay. So I mean, we are not solving the question, just go back. I'm just showing like how you just go through the algorithm. So I'm like, okay, so when I added this -3 to this one, I got -2, and I'm like, hey, each time I dip below 0, just reset current to the current number, right? So I just reset this to -3, right? But then before I set this to -3, I had actually already stored my result as 1. And as you can see, 1 is the maximum sum we have seen so far. Then I go into 4. When I come to 4, I have -3 plus 4, right? That is -1. But I know that each time I get a -1, I should just reset it to be the current number, right? I'm like, hey, start accumulating the sum from this current number, right? Because all these guys are just going to give you a net loss, right? So if that happens, what I do is that I reset this guy, right, to 4. That is the current number. But before I reset, I have to check, is the current sum I have so far bigger than result? Here, the current sum I have so far is -3. It's not bigger than result, so maintain result. But I reset this guy to 4. Then we continue. We move I here. This is -1. I is now pointing to -1. So 4 minus 1. That is 3, right? 3 has not dipped you down below 0. So continue, right? Don't reset anything. So I move I to here. I move I to the 2. I'm like, okay, so this is 2. So I have 3 to be my current. 3 plus 2. Okay, that is 5. So see, my current is bigger now. That is 5. So I'll continue. I'll move I to 1. If I move I to 1, so that's like I add 1 to the 5, right? And that gives me 6. Oops, looks like I have a bigger current now, right? That is 6. Then I move, but note that on each iteration, you actually update result. Sorry, that's something we should have done. So result went from 1 to 3 and so on, and it's at 6 now, right? Each time you move I, you update results, right? Results will hold the maximum of the two values. So I'm at, I is at -5 now. So I'm at 6 minus 5. 6 minus 5, that is 1, right? I want to reset again, but I'll compare current to result. So a result will be the maximum, right? And 6 is bigger than 1. So I just continue. Then I move to 4. So that's 1 plus 4, which is 5, right? And then I'm done, right? And this is 5. So I'm done, right? I'm like, at the end, result is going to hold my value. I'm done explaining the interview. The interview will be like, okay, I think that looks good. But let's see. Why did you reset current to the current number again if it's less than 0? Be like, oh, so the reason why I did that is because current, right, is kind of like finding the sum of all the numbers I have seen before nums of I. Now, if current is 0, that means that all those numbers that I saw before the current number are negative, right? Like they're just going to bring they're just going to like bring the sum down, right? So like if I have -5 and 5, right? Why do I need to start the summary from -5? I can just discard it, right? I'm like, okay, I think that's fine. I think that makes sense. So what do you think the time complexity of this algorithm? Okay, it's O of n, because we loop through the list just once with our I pointer. Okay, yeah, I think it looks good for me. We can go ahead into coding, right? So you realize that we go through the algorithm perfectly before we go into the programming portion. I have not written code, nothing yet. Some interviewers are so good that sometimes even if you finish this portion and both of you agree, that is when, and you don't even get to finish the code, they'll literally move you on, right? So now let's assume you did the one example and it looks good, right? You can take the next example if you have time, right? And then run through the next example. But so far as one example, you see, I took kind of like the longest example, a bit complicated, right? To do that first. So the guarantee is relatively higher. Then I can go into the coding. If I go into the coding, I'm going to write a Python function and I'll call it maximum, let's say max subarray. Now the name of your function should spell out what the question is asking you to do, right? Don't go and do, so those people have been doing LeetCode, don't go and do class solution, I beg. Don't go and expose yourself there. So just write max sub array, and it's going to take, so you see, I'm talking through as I write the code. It's going to take an input nums, that is a list of numbers. And then what I'm going to do, I'm just going to find, you don't need to write specification here. You don't need to be like, find, you don't need that, right? Because we don't know what you're doing here. Okay, so I'm going to initialize, as I mentioned here, my current is just going to be 0. It's going to start at 0, and result is going to be minus math.infinity. Now, why am I doing this? Now look at something here. Whenever you're solving a programming question, right, and they're asking you to find the maximum of something or the minimum of something, right, and you'll be initializing a variable which you compare with, some value you'll be you'll be considering in future. Initialize that value to minus math.infinity. What I mean is, assume you'll be finding, let's say, the maximum number, right? Assume you'll be finding the maximum number in some list, right? You want to initialize that your accumulator to be the lowest number possible, right? So for instance, let's assume that my list contains 1, 2, 3, 4, right? And I want to store the maximum of this list inside result, right? Ideally, you should initialize result to the smallest number possible, right? So here I could have initialized results to 1, right? So that each time I compare 1 to anything here, right? If that thing is bigger than 1, that thing will be updated, right? So that's how you work it out. If you're finding the maximum, initialize your accumulator to the smallest value possible, the minimum possible. If you're finding the minimum, initialize your accumulator to the maximum possible. Somebody could also do min of nums, right? Any of them is possible, right? But we just do minus math.infinity. Somebody can also do float minus inf, but I just do math.infinity. Does that make sense? If you're finding the maximum, initialize your accumulator to the minimum possible. If you find the minimum, initialize it to the maximum possible. Now, assuming the reason why we didn't do, so realize this one, the numbers can be, the sum can actually be negative or positive, right? But it can never be smaller than minus math.infinity. So that's just something to keep in mind, right? So you will like, okay, so what I'm going to do now is that I'm going to just use a for loop. So here I used a loop variable I, but here I'm going to use a for each loop, right? So I'm just going to do for n in nums. Then at each point, what I will do is that I'll check, I'm just going to add the number to my current as we did. So whatever current is, I'll add the current number to it. And then what I'll do is that I'll check if current has gone below 0. If it's gone below 0, I'm going to reset current to whatever n is. That's like, okay, start afresh from this number. Then on each iteration, I'll consider result, right? I'll make result with the maximum of whatever result it is in current. And then here, and then I'll return result. And that's what I have here, right? Now, when you're done writing the code like this, you do not stop. Someone said, why don't we initialize the current? Okay, the reason why we can't initialize current to minus math.infinity is because current is a running sum, right? Like current is what you'll be adding these things to, right? And that's a question an interviewer can ask you, but why is current 0 instead of this? Right? Because current, you're going to add numbers to it, right? If you add 1,000 to minus infinity, it's still minus infinity, right? These two variables are serving different purposes. Result is just going to store the maximum sum you have seen so far, or the maximum value of current you have encountered so far, right? So this is the only place we use result, right? But current is going to be we're going to add the numbers we have seen, the numbers in our nums list to current, right? And if you be adding something to things, you initialize your accumulator to 0, right? Because any number plus 0, right, it gives you that number, right? So here for the first time, on the first loop iteration, current is going to be minus 2, right? If current was minus infinity, it's going to be minus infinity plus 2, plus minus 2, that's the minus infinity, right? So that's why we do that, right? Okay, good stuff. So when you're done writing the code, you don't say, I'm done, it should work. No. Bro, almost like there's this thing that there's no like program without bug, bugs are everywhere. So what you do now is you're like, when you're done doing this, what you do next is to take an example, like the example they gave. As usual, I said, use the example they gave you. That's the only thing you're guaranteed has the answer. Take that example and come in here, right? So you can be like, now I'm going to run through with this example. Now you can use these comments. So here, this is nums, right? This is what my nums is. You can literally just write this thing down here. Like this is nums, and my current is 0 now. So I'm going to also, have current to be 0, and this guy is minus infinity right here. It can be like minus infinity. So for n in nums, on my first loop iteration, n is minus 2. See how I'm walking through it, just like you do with the Python tutor that we discussed months ago. Current plus equals n, right? So my current, what is the value of current? We all know current, right? From here, current is 0. So current plus equals n. So current is 0 minus, and n is, I don't know if this is confusing to people. Let's do current is equal to current plus n. So we know what n is, right? N is minus 2 here, right? And we know current is 0. So 0 minus 2 is minus 2. So you can either do this, be like minus 2, or you can even just use arrows, right? To just show, how it's changing, or you can even just delete the initial one, right? And just have this, right? But for clarity's sake, let's just do this. Then we come here, we're like, if current is less than 0, current is minus 2. Minus 2 is less than 0 indeed, right? Then current is also minus 2, right? Just reset this. It's basically the same thing, right? Then you go ahead. You're like, result is equal to max of result. Result is minus infinity, right? But now minus 2 is bigger than minus infinity, right? But now result is minus 2, right? Then you come again. What does n change to? N changes to 1 now. You're like, okay, now you have minus 2 plus 1, right? That gives me minus 1. Then I can be like, okay, is minus 1 less than 0? Yes, it is, right? So this is true, right? This is true now. Again, current should be set to n. So current is currently minus 1, but it's like now set it to n. And what is n? N is 1, right? Now, as you do this, things become so clear. Now, one important thing of this is when you have a coding problem that involves recursion, right? I remember in 2021, when I did my meta interview, there was this coding thing there was this question I had that involves recursive calls. And if I hadn't visualized it this way, I would literally get so lost, right? So I'm like, okay, it's 1 now, right? So now I'm here on this line. Result is called max of current result is minus 2. Comparing it to 1, 1 is bigger, so I'll update results to 1, and then so on and so forth you go. After you've done going through one example, interviewer will be like, are there any other examples you can think of? You're like, if all my numbers are negative, right, you realize if you look at this, you're going to choose the smallest negative number, right? So I'm just giving some edge cases. If all the numbers are negative, right, you're like, oh, for that, the answer is actually going to be, the most positive negative number. I mean, the smallest negative number, right? Because that's what this guy would choose. And be like, can the list be empty? If it's empty, what you can ask it. So if it's empty, what do we do? It's like, we can return 0 or something, or the list will never be empty. You see, I'm now considering those edge cases. After I've written my code and it passes for their test, then I'm thinking of other tests I think might break my code or will strengthen the fact that my code is correct, right? So then I'm like, I think this should do. I think this should work. Assume they are now asking for time complexity and you're not sure of the time complexity. Just take it in parts, right? I'm like, this is just initialization. Those are all just constant time stuff. This is looping through all the numbers. And assuming that the length of numbers is n, is uppercase n or p or whatever, then here is O of n. This is just constant time operation. This is also constant time. It's constant time. Okay, so it is O of n times constant. That's just O of n. And that I'm done. You're like, okay, yeah, I think that looks good for me. Good. So that's what we have for the coding problem. Do you have any questions for me? Yes. Please, whenever an interviewer asks you, especially in an interview, in a technical interview, do you have any questions for them? The answer is yes. Yeah, Jesse, you have a question? You can ask.
So I would like to know, are there instances where, for a particular problem, if you are looking at time and memory complexity in best and in worst cases, is there an instance where an interviewer will be like, okay, so this is the time and memory complexity for the code. So is there a way to optimize it to be a constant time or amortized time, constant time?
Because as I said, it's so flexible, it's so open-ended, right? They can be like, the interviewer can like anything, right? But I think they're not going to give you something impossible. Now, there's a way we can do this question in worst time complexity, worst case, right? We can actually do nested for loops, right? And still compute it. So like I can be like, if I start at -2, I can actually do O of n squared. So start the left pointer here and try to expand it out and find the maximum possible. You can even do worse than that, right? Then you assume that was the first solution you proposed, like, but can we do better? Then you're like, let's see. Yeah, so those are possible. I've been in an interview where they give you the code, then like read the code and tell them what the code is doing. So don't just go into an interview, right, expecting just one thing you learned, right? You have to be open-minded, you have to be so flexible, right? But the little you have learned, you try to, adjust it to fit, the situation. So everything is possible in my experience, every single, but no one is going to give you some tough, going to be like, can we do this in constant time? They'll give you what is reasonable, what is possible, right? If you think is reasonable, just be like, yeah, I can ask ChatGPT, that's constant time. But everything they're going to give you is going to be like very doable, right? Like, I mean, like, they won't give you a time complexity that is impossible. there's a group of problems, a group of algorithms that group of problems that cannot be solved in polynomial time, right? We call them NP complete problems, right? They are NP. NP does not mean hard or something. NP complete simply means we have no polynomial algorithm, no algorithm to solve them in polynomial time. The best polynomial thing we can do is to approximate their values, right? So for instance, let's say I don't know if people know the traveling salesman problem, or what do you call, or what do you call, or set cover or vertex cover, or any of those problems. That you can't solve them in polynomial time. Polynomial in term as in like n squared, n to the power. Right now everybody thinks n squared is bad. Trust me, n squared is super good. Like in higher level algorithms, you realize that like if you can get an algorithm that is n to the power, n to the k, right? We tell you that is polynomial time. That is that is good. That is really good, right? But we know ones like 2 to the n or 2 to the something, those ones are bad. But n to the something, n to the 4, n to the 3, n to the 2, these are good. But there's some problems you can never, like, the current, no, I can't say you can never, maybe I'll be the one to discover it. Currently in the world of computer science, no one has, got a polynomial time solution. And the coolest thing about these problems is that we have found a way to reduce them. What I mean is that we can take the two problems A and B, right? And you can convert A into an instance of B, or take B and convert it into an instance of A. So if at any point in time, any of you finds a polynomial time solution for any of them, let's say for A, just let me know, right? Then I can just, get a Turing award, and then I'll share it with you. If you find the solution to any one of them, you can solve all the others, right? Computer science is so cool. And it's typical historical computer science. That we call them NP complete problems. Like one instance of any of the problems can actually be converted to another instance of another. There's a bunch of problems with that. Maybe if you are done with time, I can actually show you a couple of them. Very, very cool stuff. Yeah, CS is very cool. Yeah. So, oh yeah, we were at the portion where you're done solving the coding problem. They're like, so do you have any questions for me? Please, the answer is yes. The answer is yes. So they're like, okay, yeah. So maybe when they were telling you about themselves, there was something they said which really enticed you, right? Maybe they're like, I've been at this company for 10 years. You're like, wow, right? Then when during the question time, you're like, so why, what really got you stuck at this company for this number of years? Then they'll begin to tell you essays, right? Okay, so I really like my team, and this, they may be lying, but who cares? It's an interview, right? Just listen to them. You're like, okay, have they had a chance to work with any intern or any new grad? And if so, in their opinion, what makes an intern or a new grad stand out, right? That's one question. Another question you can be like, so what is the most exciting projects they have worked on? That's another thing. Question you can ask them is, throughout their career, is there something they did that they believed really helped them? That's another question, right? Please don't go and ask, did I do well on this interview? You never do that. Like you're boxing them, right? What should they tell you, yes or no? Right? You may never even see them in your life, right? The questions you ask them should be, not even related to the interview that you just did, right? Should be something extra, something external. How does this company support you in your career, in your development? Or maybe I was first at this company, so we're like, okay, so company A and company B and this current company, what are the differences? How do they support you, right? And these are just questions you can ask. When you're done, you're like, thank you. Now let me touch on a few things. When you're doing an interview, see this question, I didn't get stuck, right? Sometimes you get stuck at some point, right? Then the interviewer gives you a clue. When they give you the clue, make sure you understand that tip, that clue they're giving you. If you don't understand, ask them to repeat it. Then when they repeat it or they give you the clue, you just say thank you and move on. I have friends, if you give them a clue in an interview, they feel like they have failed the interview. No one is expecting you to do things perfectly and on your own. That is false, right? Like you get stuck. Like one of my Facebook interview, my Meta interview 2 years ago, I converted this thing to this, and I'm come back and I'm like, now how can I convert this to this? Like, what about if we find them mid? And I'm like, oh, right, we can just find them mid. Thank you. Then I just moved on, right? I did one interview with one company, was it like Mongo, like 2 years ago or so? And when they gave me the offer, there was one thing they said that, one of the feedback the interviewers wrote, the engineers wrote, was that he's able to take feedback and run with it, right? That is how it works. They intentionally want to give you feedback, right? Give you some clue, give you some tip. Then they want to see how you embrace that tip, that feedback, and then run with it, right? So if an engineer gives you an interview, please don't feel disheartened. It is not a disqualification. It's a disqualification if you don't understand the tip and if you can't exploit it. So if they give you the tip, make sure you understand. It is so important. Some interviewers come to the interview with a question they know. Like many students cannot solve this unless I do it with them, unless I help them. So they're expecting you to work with them. That's why it's important to connect with them at the start, right? So when they give you the tip, just say thank you and then move on. It's fine to get stuck and be like, so here, if I don't reset, so assuming you didn't have this thing, so assuming you're like, yeah, I didn't reset current enum, so why is the thing not computing the right thing? Let's see. I'm not getting the right value. Let's see. But But because you've already connected with the interviewer from the start, he can just throw that tip in. It's like, what if we reset? So you're like, what if we reset, current? You're like, oh, right. We reset current. We reset it to 0 or to the current number. He's like, let's try 0 and see first. You try 0, like, it's not working, right? Then you try it again, then you do the next one, then we reset it to n, right? So it has to be like a flexible, discussion between you and the interviewer. So please, that is just a brief, overview of how you do a technical interview. Somebody has asked me this question for Cornelius. Have you had a question you have never, like, you had no idea how to do it in an interview before? Like, before going on, in my experience, I think it's happened once. It was for Bloomberg in 2020. That was actually the first technical interview I did in my life. No. I mean, in recruiting, I did one prior, like in freshman year with a startup with Kahila. But I mean, like these other companies we applied to. Remember, was my first one. Like, if the woman giving this question, I had no idea. Actually, I don't even think I can. I don't even know if I can solve this problem. Maybe it was Alien Dictionary. Then if it was Alien Dictionary, then she's very wicked. Because I was a sophomore, first semester, give me Alien Dictionary. That's a lead code hard question. I have no idea what was going on in that thing. So, but then the other interviews I've done, most of the questions I've not seen before, but by God's grace, I've practiced to some extent. So I'm able to, to like apply it and solve the question. Sometimes I'm able to, sometimes I go and just drop in my head, right? But I think to increase your chances, right, just practice. We have this thing like, the more you practice, the luckier you get, right? When I say practice, I mean lead code, definitely practice some of the problems we advise, we suggest. But other than that, write code, right? Like write code often. Just build projects, just do side stuff, right? Because the more you do these things, the more your brain begins to function algorithmically, right? Like write some very nasty, JavaScript code. But then because you've been practicing DSA, you try to optimize in those things. So please write a lot of code, practice a lot. Definitely practice. Like practice is so important. I'm like, look at people's code. Even if you will solve the question, go to the Lead Code Solutions tab, look at some guy's nice code, watch a video solution, and revise often, and it should be fine. Looks like, we have 2 minutes. I wanted us to close early today, like 35 minutes. Does anyone has a question? Anyone? Did how we went through this whole thing make sense? You can rewatch I think I'm recording. You can actually rewatch it, and that is just how you go about the technical interview, right? Definitely write things down because your accents may not even be clear to them. But by writing it down, you try to you communicate clearly. When you're done, walk through your code, by using comments like this. When they give you feedback, just say thank you, and then you move on. Don't get beaten down. If you can't solve the question, struggle through it, hustle through it. That's fine. What do you call it? You can add more tests, right? You can add more. It can be like, so let's run some more tests here. You can add your own test cases and so on and so forth. If there's an object-oriented programming question, right? Then you can be like, okay, so let me create an instance of my class C1. Then be like, so class. So I'm going to do it. I'm going to first do a get.get. Then I'm going to do a .put, right? And so on and so forth. As you solve my, you come across many of these things. So yeah, that's it. Anyone has any questions? Any questions? Yeah, definitely practice a lot. Like just practice. Like if you learn, like I'm picking up C++ now. Sometimes I just open Lead Code, just questions I've solved before, just try to now do them in C++. I've done them in Python and maybe Java. I'm just doing in C++ now. I just integrate things as part of your life, right? And then you'll be good. Okay. That's what we had for today. Does anyone have any questions? Those with mock interviews booking, we will definitely do it. We definitely will. But at least, like, I hope this workshop gave a very good overview to one like an interviewing format, right? Yeah. Anyone has any questions? Anyone? Any questions? Anyone? Any questions? No questions. Okay, no questions. Good stuff. All right. Let's meet goal next week and let's see what we have. All right. See everyone later. Bye. Oh, yeah. You can DM me on you can DM us on Slack and I'll definitely get back to you then. So yeah, just on Slack and then we'll get back to you then. Okay. All right. Catch everyone later. Bye.